So we have a new addition, let's say, in the AutoML part of the platform, and that is the serverless forecasting. So what is this new feature exactly, Lara?
Yeah, so for those of you who already know AutoML, this is going to look very familiar, but Mosaic AI model training, serverless forecasting, it's basically something that improves the existing AutoML forecasting experience with serverless compute, but also Unity catalog support. You have access to deep learning algorithms and basically just an upgraded interface. What it tries to do is just to simplify forecasting time series data. It automatically selects the best algorithms, hyperparameters, like what we're used to with AutoML, and it runs that on fully managed compute resources in an
Excellent. So what do you need to get started?
Yeah, you just need training data with a time series column, which is saved as a Unity catalog table. Also, not to go into too much detail, but as shown here, if your workspace has secure egress gateway enabled, then pypy.org must be added to the allowed domains list. So you can look at the documentation for more information.
Excellent. So are we planning to show a demo?
Yes.
Yeah.
So if we go into the experiments page, it's very easy. You just go here, you start your training, and then you provide like some training data. So let me just take the same that I'm already using here for a previous experiment. So you give it a table. And then you select the time column, that represents the time in your data set. I think this column must be of a type timestamp or a date. Otherwise, it won't work. So here I have this column hourly timestamp. Then I choose the forecast frequency, so the unit that will define the forecasting interval. So here I'm going to select hours, and then you can decide your forecasting horizon. So how much you want to forecast in the future. So you can put 1, 4, 7, etc. Then you're going to predict something. So here it's energy because it has to do with wind turbines. And the prediction data path, so that's something that's optional, but you can select the location of where you're going to have this. So for example, here I can select, my schema under this use catalog and, add this. We're going to have a table with all the predictions that are computed, and then you can register the model that's created. So again, here I could choose like this. Then you have a bunch of advanced options. So you can give it a name, the directory, etc., and a bunch of things such as primary metrics, preferred training frameworks, so that you can, decide what you want, and a lot of other things that you can select. So it's
Nice.
pretty cool. And then you just start your training, and it's going to take like around 5 minutes, I would say, between 1 and 5 minutes. But you can also then just take a look here at something that I ran a few days ago. This is what you get in the end. And it will give you like a lot of runs. And then the best forecast model was created by the run prophet. And from there, you can get a batch inference notebook, that you can take a look at, but also you can view the predictions that are logged in the path that we had specified before. So if you look here, I had done a simple experiment. So I think it was just forecasting an hour in the future, but you can see I can find it here. And then I had also chosen to register my model here. So yeah, it's very easy. And then if you look at the documentation, I quite like that they put a table that looks at serverless forecasting versus classic compute forecasting. So you can take a look to see how the governance works. So for example, with serverless, the great thing is that all the models and artifacts are registered to UC. Feature store integration not supported yet with serverless forecasting, whereas it's supported for classic compute forecasting. So something that you can take a look at.
Amazing.